Good morning. We are busy with the trigonometry questions of past question papers, and this is then trigonometry of November 2016. So question 5, 6, and 7 of the November 2016 paper. Let's start. It says in question 5.1, given that sine 16 is equal to p, sine 16 is equal to p, which I can summarize as p over 1. So I'm going to make a triangle here in quadrant 1, where that is because 16 lies between 0 and 90. Sine is p over 1, and I can get that side by using Pythagoras. I'm sure you will all be able to get there. And okay, then I can look at the questions. So determine the following in terms of p without using a calculator. So I'm going to look at 5.1.1. Sine 196 I can write as 180 plus 16. So I'm going to do that. Sine 180 plus 16, which is one of my normal reductions in quadrant 3, where sine is negative. And if sine 16 is p, then negative sine 16 is just negative p. I don't need the triangle for that one, but in these questions I know already the triangle is coming, so I just draw that up quickly as I start with the question. 5.1.2 cos 16 indeed is then going to be root 1 minus p squared over 1, which is then that. Okay, question 5.2, easy starter for the trig part. Given that cos A minus B is cos A cos B plus sine A sine B, this is one of your compound angle formulas. Use the formula to derive a formula for sine A plus B. Right, they do ask all of these three questions. Use this formula to derive sine A, the other three, sine A plus B, A minus B, and cos A minus A plus B. Make sure you know how to derive them. They come from playing around with positives and negatives, and also 90 plus minus, where you change from sine to cos. So they come from that, and then using your original compound angle formula. So to derive the formula for sine A plus B, let's do that, but also make sure as you do your studies that you know how to derive all three. Okay, sine A plus B, I can write as cos of 90 minus this angle, which is A plus B. And then if I multiply in that bracket, I have cos 90 minus A minus B. Right, and I want to use the formula for cos A minus B. So if I look at this, cos A minus B, I can use that formula with 90 minus A as my typical A value and B as my typical B value. So the formula for cos A minus B is cos A, which is now 90 minus A, cos B, plus sine A, which is now 90 minus A, sine B. So I use this formula. If it was the sine A minus B formula, I just want to mention that this would have been now a minus, and then if you multiply this out, this would have been a plus. Now to use the minus formula to change this plus, you can just change this into a minus B, and then your B that you substitute in here is just going to be negative. That's how you would deal with that, by the way. Okay, so cos 90 minus A is going to be sine A cos B plus sine 90 minus A cos A sine B. And there I have derived the formula for sine A plus B does expand into this by using the cos A minus B formula. Okay, question 5.3. says simplify root of 1 minus cos squared 2a over cos minus a cos 90 plus a completely, given that a lies between 0 and 90, so an angle in quadrant 1. Simplify, I have 1 minus cos squared 2a over cos minus a cos 90 plus a. If you already watched the formula in 2015, I also mentioned that in that video, but negative angles you can see as they lie in quadrant 4. If I have the theta 180 minus theta 180 plus theta, and then typically in quadrant 4 I have 360 minus theta. But if you think about this, 0, 90, 180, 270, 360, 0 and 360 lies at the same place. So 360 minus theta and 0 minus theta, which is then minus theta, both lies in quadrant 4. When I see this now there, I just thought of that. Okay, so 1 minus cos squared is sine squared, right? You have a formula from grade 11, sine squared plus cos squared is 1, so sine squared is 1 minus cos squared. If I just jump the cos over, so I can sort of make that 1 minus cos squared. I'm going to replace with sine squared, and the angle is 2a, keep it like that. Over, this is quadrant 4, so I have cos a. In quadrant 4, my cos is positive. So cos a and cos of 90 plus a quadrant 2, where cos is negative. So I'm going to change this into negative, but sine a. You must always remember at 90 to 70 plus minus to change from cos to sine, sine to cos. And then I can take that square root and the square will cancel one another. So that's going to be sine 2a. Sine 2a over, and here I now have negative cos times sine is negative sine a cos a, which makes me think of the formula for sine 2a, but I needed 2 there, which is fine. I can put the 2 there by multiplying with it, 2 over 2. So then I have the 2 there, but it's also going to produce a 2 at the top. Okay, and then 2 sine a cos a is sine 2a. So I have 2 sine squared 2a over negative sine 2a. And, well, I think most of you can see you can just cancel the one sine 2a with the other, with one of those two. But just to make it clear for those of you that don't see, I'm just going to write this sine squared 2a as sine 2a times sine 2a, just so you can see what I mean. So I have sine 2a, and then this one can cancel with one of the two, but the other one is going to stay there. And 2 by the negative, I'm just going to put now on top. So negative 2 sine 2a. There, I'm done. Okay. Given cos 2b, question 5.4, cos 2b is 3 over 5. And b lies between 0 and 90. Determine without using a calculator the value of each of the following. Now, my inkling is to go and draw a triangle in terms of my triangle with, let me just show you here quickly, with an angle 2b, and then cos is 3 over 5, so I put in those values, and then from there work out the missing side with Pythagoras. That's my first idea, but be careful, there's something I notice. Okay, so the idea is that I must work with a triangle. Now I want to just go put 2b is 3 over 5 cos, so 3 over 5 like that, and work out that side. Whoops. Angle 2b, 3 over 5, and work out that side. But now if I look at the question here, all of them asks me determine without the value of a calculator cos b, sine b, cos b plus 45. All of these has only b. I don't want my sketch to have a 2b because none of the questions I can read from the sketch then. That's not ideal. So you can maybe have your sketch in 2b and then rework all of this to something in terms of 2b, but that's creating a lot of challenges. where if I just rework this to something in terms of b only, it's going to make my life a lot easier here. So I'm going to start by taking not that. Cos 2b is 3 over 5, and then replace the cos 2b with, well, you can use either one, but since we are now working with cos, I'm still going to stick to form. And replace it with 2 cos squared minus 1 is 3 over 5, and then simplify. So I have 2 cos squared b is 8 over 5, and divide by 2. So I have cos squared b is 4 over 5. And then if I take the square root, I am supposed to work without a calculator. So I'm going to make that 2 over root 5, or if I rationalize the denominator, 2 root 5 over 5. Okay, and then I'm going to have my sketch. This is a lot better. I have my sketch with an angle B, and cos is adjacent to root 5 over hypotenuse 5, and I'm going to work out that side by using Pythagoras. It's going to be 5 squared minus 2 root 5 squared. So that is 25 minus 4 times 5 is 20, so 5. Then that is root 5. Okay, great. So now I can answer my questions. So to answer the first question, 5.4.1, cos b is 2 root 5 over 5. I have that. Oh, great. 5.4.2, sine b, from my triangle opposite over hypotenuse root 5 over 5, and 5.4.3 cos b plus 45. I'm going to just use my formula there. Is going to be cos b cos 45 minus sine b sine 45. And then for the b values, I'm going to read from my triangle. So cos b is 2 root 5 over 5. And cos 45, for the 45s, I'm going to use my special angles. Cos and sine 45 is root 2 over 2. Whatever method of special angles you use. Sine b is root 5 over 5. And sine 45 also root 2 over 2, and then I can just simplify from there. So I have 2 root 5 times root 2 is going to be root 10 over 5 times 2 is 10, minus root 5 times root 2 is root 10, and 5 times 2 is 10. This is two fractions on a common denominator, so I can just subtract the numerators from one another. And since I have 2 root 10 minus 1 root 10, that's just 1. You can add and subtract roots just like you do x's. So same as 2x minus x is 1x. 2 root 10 minus root 10 is 1 root 10 over 10. Right, so there is my simplified answer for that. That's question 5. Let's look at question 6, trigonometric graphs. Okay, in the diagram of f, of the graph of f, 2 sine 2x is drawn. Right, so there's 2 sine 2x drawn on the graph. On the system of axes on which f is drawn in the answer book, draw the graph of minus cos 2x. Okay, I'm just going to draw it on this one. Minus cos 2x. Now cos graph normally looks like that between 0 and 360. Okay, so that, just by the way, that 2x is going to shrink the graph by factor 2. So instead of between 0 and 360, it's going to now go my entire cos graph between 0 and 180. And the negative there in front negative cos 2x is going to also reflect. So I'm going to shrink this graph between 0 and 180 actually, which means that's 90, 45. So every 45 degrees I will have critical values instead of every 90 degrees. And then also I'm going to do a reflection, meaning the graph is actually going to look like that, not like that. So I'm going to have my cos graph there, and this graph here has graph paper on it slightly at the back, which is marked every 45 degrees, which is ultimately what I want to do anyways. Okay, so I'm going to do that every 45 degrees cos graph -1, 0, 1. There we go. And just also extend it to the other side. There, this graph is going to look like that. Okay, by hand. Just quickly want to show you, for those of you that always struggle doing you, if you're a bit if you find this a bit challenging to draw the graphs from just thinking that's a reflection and a that, and this is the effect, ta-da, there it is. I think depending on how your brain works, we don't all work the same. Some of you might find this is a lot easier, but some of you might just find, I'm not sure what, I don't know what it means and how to do that. There is another way. Let me quickly show you. On your calculator, you're going to start by mode, then you're going to choose table, so option 3. Then it's going to ask you what is the equation. Well, you can type in this fx, but I'm still going to work with this. I want to plot the graph of negative cos 2x. So I'm going to plot the graph of negative cos 2, and the x you see there is an x on your calculator. So I'm going to use the alpha button to get that pink x. So alpha, then it makes an x on my calculator, close it. Okay, so I type my equation that I want to sketch a graph of, and you can use this for trigonometry graphs or any function for that matter, parabolas, hyperboles, exponential, anything. You can create this table on your calculator to sketch the graph. Okay. Right, so I type my graph in, then I press equal to enter. Okay, so I enter. It asks me if I want to work with another equation. It can produce more than one set of tables with various equations. I don't want to do that now. I just want to work with the one equation that I want to sketch. So I'm going to skip this by just pressing equal, and then it says start. Now it's going to ask you start and end. Your start point is where do you want to start the graph from -180. Your end point is going to be 180. This may vary depending on the question. You have to know what the start and end and step does. So just quickly follow. My starting point for this graph is from -180 up until 180. So I'm going to start at -180, equal to enter. And I want to end at 180, equal to enter. And then the step means if you want to take a table, this what I'm busy doing here is I'm busy creating a table of x and y coordinates like that, right? And I want to start at 180, -180. That's the value that I typed in the start, and I want to end at 180. So I want to go from -180 to 180. The step means, do you want to take every 30 degrees, every 45 degrees, from -180 to 180, in steps of how many do you want to take? So if you type there every 90 degrees, it's going to have here values for x, -180, -90, 0, 90, 180, every 90 degrees. That's your step. So on this sketch, since this sketch is already marked every 45 degrees, I think a good step would be 45 degrees. Mostly for trigonometry graphs, a good step is 30 degrees. Or you can decide depending on what you have there in front of you. I mean, for a parabola, you're not going to have every 30 degrees. A good step there would be 1 to plot, say, from where x is -4 to 4. and take a step of 1, then it's going to produce -4, -3, -2, -1, 0. Okay, so I'm going to take a step of 45, and then it produces a table with, you see, the table is just turned, not like this, it's just turned sideways. So where x is -180, my y value is -1. At -180, my y value is -1. -135, my y value is 0. -90, my y value is 1, you see, and it produces these coordinates, and you can go down with your arrow button. There's -45, 0, 0, -1, that you can just plot all of these points, and then there you have your graph. Okay, that's just another method. Okay, all right, and to clear the screen, because now if you see your calculator does something weird, to clear the screen, I'm going to use that clear function, and you can somewhere clear all, shift clear, and then choose option all. Whenever your calculator is doing anything weird, that's what you do. Reset all, press equal to say yes, reset all, press IC key, and there my calculator is fine again. Okay, all right. Write down, so there's my sketch. Write down the maximum value of fx minus 3. So my fx is the graph that they sketched on here. Minus 3 is going to take this graph and move it down 3 units. So it's currently between -2 and 2. Move it down 1, 2, 3. Then the maximum is going to be at -1. The maximum is currently at 2. If I move it down 3 units, 1, 2, 3, the maximum is going to be at -1. So write down the maximum value. It's going to be 6.1 is a sketch. 6.2, my maximum value is going to be at -1. If they ask the minimum is currently at -2. Move it down -3, -4, -5. Then the minimum value is going to be at -5 if I move it down 3 units. Determine the general solution of fx is equal to gx. Okay, general solution. Fx, which is 2 sine 2x, is equal to gx, which is negative cos 2x. Okay, I have a 2x and a 2x, so I'm not going to change now to the double angle formulas, because since both this is already in the same angle, I'm just going to work with an angle 2x. To get one trigonometric ratio, I can divide both sides with cos 2x, then this becomes sine 2x over cos 2x is tan 2x, and cos 2x over cos 2x is 1. So I divided both sides with cos 2x to produce this, and now I can just divide by 2. I don't know why the camera is pulsing like that. Okay, tan 2x is -1/2. And then, as I said in the previous video in November 2015 paper, to get the general solution, you need to take shift tan, but take the positive value. Even if that's negative, you take a positive value. Shift tan 1/2. Right. And then that's going to give me my reference angle, 26.57. 26.57, and then that's the first thing, is even if that's negative, you keep it positive, and then it produces an angle in quadrant 1 that you can go place in the quadrants where the ratio is negative. So tan is negative in quadrant 2 and quadrant 4. Okay, the second thing that's important with general solution is if you have a complex angle here, meaning not just only x, it's 2x, please don't solve it here. So don't write here x is 13 comma something. First place the 2x as it is in your quadrants 2x. To place in quadrant 2, I'm going to take 180 minus theta, which is 153.43, 153.43. I'll talk about the K360, K180 thing now. All right, and then after I placed it in the quadrants, only then do you divide with the 2. Okay, so I have this reference angle 26 in quadrant 2, 180 minus that is giving me this, and in quadrant 4, I'm going to use 360 minus that. 360 minus 26.57 is 333.43, 333.43 plus K360. K is an element of set. Right, I just want to mention some of the textbooks say that whenever you have tan, you can write this plus K180 with tan. With sine and cos, you write plus K360. Well, that's correct, but technically, if you write plus K180, it's only necessary to write the first quadrant because the K180 just produces the answers for tan. It produces both these answers. Or if you write it in 2 quadrants, you stick to K360. I prefer to write K360 always and write it in the 2 quadrants. Then I do the same thing for sine, cos, and tan. So I write it in my 2 quadrants and plus K360. But if you write plus K180, then it's just necessary to actually write the bottom one, the top one. Because if I make this plus K180, it just produces both these. If I write both these plus K360, it produces let me try and explain it like this. It produces a number pattern that starts at, say, 153 plus 180 plus 180 plus 180 plus 180. If you write it in the 2 quadrants, then this one plus 360 plus 360 plus 360 and this one plus 360 plus 360 produces the same pattern. I don't know if that makes any sense to you, but yeah, you have I think for the struggling learners, just keep on writing as you do with sine and cos in the 2 quadrants plus K360 always. For the learners who understands the more challenging stuff, you can, but only for tan, not for sine or cos. Can only write for positive in quadrant 1, for negative in quadrant 2 for tan, and then don't write the second one, just plus K180. It produces the same thing. Okay, and then I want to divide by 2. Since I have this value on my calculator, I'm just going to do this one first. Divide by 2. Divide by 2 is 166.715, so 72. And divide by 2, producing there 180. And then this one, divide by 2, divide by 2. Divide by 2. Okay. There we go. So there's my general solution. And then hence determine the values of x for which fx is smaller than gx in the given interval. No, between minus 180 and 0. So only there where fx is the graph that was there, is smaller than gx is the graph that I drew on there. So below, I'm looking where fx is below. Here fx is above, above, above. From there, which I'll get that now, below, below, below to there. I need these 2 coordinates there. Okay, now I can use my general solution. That's why they say hence, to produce those 2 values there. So I have the 76.72, which is obviously that point. Can you see there? That point is going to be at 76.72, and that point is 166.72. 166.72, and this basically means from 76 I can add and subtract multiples of 180. So I can make a number pattern arithmetic from 76 plus 180 plus 180 plus 180 also minus 180 minus 180 minus 180 to produce more answers that are valid. Now I'm looking for those two x values. So I'm going to take the 76.72, which I have on my calculator, and I'm not going to add because that's going to go that side. Let's subtract 180. It is minus 103, which is obviously between 90 and 180 is that one. Minus 103.29, okay, is that cutting point there is minus 103, and that cutting point I'm guessing I'm going to get by taking 166.72 subtract the 180 gives me minus 13.28 minus 13.28. So where f is below g is from there to there, minus 13 to minus 13, and you can write this in set builder notation or in interval notation. So I can write x lies between minus 103.29 and minus 13.28. This is interval notation. I exclude the values because the question said fx smaller than gx. If it said smaller equal, then I will also make block brackets here. Or you can write the answer, same thing, but you can write it like that. X lies between minus 103.29 and minus 13.28. It's just two different notations of giving the same answer. Okay, and that's question 6.4. Let's look at question 7, which is your 2D, 3D type problem. Sine, cos, and area rule. Okay, so E is the apex of a pyramid having a square base. A, B, C, D. O is the center of the base. EBA is theta. I must just make sure EBA, it's the side of the pyramid. So if I look at the pyramid from the outside, there's now 3 triangles that I can see from the outside, and this angle is the theta. Okay, AB is 3 meters, which means all of that is 3 meters as well, and EO is the perpendicular height of the pyramid x. Okay, volume of a pyramid I can work out by a third times the area of the base times the perpendicular height. Calculate the length of OB. Okay, now something important to know of a square. This comes from grade 10 Euclidean geometry. Of a square, properties of a square, you should know that all of these sides are the same. My diagonals will firstly bisect one another, but they are also equal. They are not equal to that, so I'm just going to make another. Okay, so they will bisect one another, but they are also all equal to one another, and then the diagonals cut one another perpendicular. So I can assume all of these are 90-degree triangles, and if I have that this is 3, I want to calculate the length of OB, which is that side. That's also going to be 90 degrees. I can work with Pythagoras there. I can't name that x because there's already an x, but I can name it y. Then that will be, it's just easier to work with a letter y and y. Okay, so to calculate AB, 7.1, I can, this sketch here is enough reason. Since I'm not working with Euclidean geometry at the moment, I don't need to give all of my Euclidean reasons here. But putting this sketch here just explains to the person what I've done. I'm using those as the same, and I made that y, and that's a 90. I use the property so they can see that. So I don't actually need to give reasons here. So I can just start by saying y squared plus y squared is equal to 3 squared by Pythagoras. And then I have 2y squared is 9. So y squared is 9 over 2. I just want to check if this question says something about calculator usage. It doesn't, so I can just work out y is root 9 over 2, which is 3 root 2 over 2. I'm probably going to use this length a lot, and I don't want to keep on either writing the entire unrounded thing, or I don't want to round off too early, so I'm going to just keep that 3 root 2 over 2 thing there anyways. Okay. Alright. Calculate the length of OB. There's the length of OB. 7.2. Show that cos theta is 3 over 2 root x squared plus 9 over 2 cos theta. So I have the length of OB. The theta lies in this triangle here, right? If I open this pyramid, I draw its net. Just want to make things quite clear here. The theta is that angle. I now have this, right? I think I need this side length, which is this side length that comes up here in that triangle there. In EOB, that side length is this one. I need that one, which I have. That's x, and that's 3 root 2 over 2. So I can work out BE quickly. BE is x squared plus 3 root 2 over 2 squared, which is x squared plus, that's 9 over 2 when I square it. 9 over 2, then BE is going to be root of x squared plus 9 over 2. And then I want to use the cos rule. So those two will obviously be the same length, also properties of a pyramid. And that's my theta. So I'm going to use that as one of my side lengths. Cos rule. A squared is b squared. Oh, I'm completely off the screen again. A squared is b squared plus c squared minus 2bc cos A. I'm going to use this angle here as my A. So across from that, which I have, this is root x squared plus 9 over 2, which is also this, and that side length there is 3. So that's my theta. This is going to be my A, which is also that. So this one, which is then x squared plus 9 over 2 squared plus b and c are those 3, and that doesn't really matter. So 3 squared plus root x squared plus 9 over 2 squared minus 2bc squared plus 9 over 2 cos A, which is then cos theta. The square and the square root cancels, leaving me x squared plus 9 over 2 is equal to 9, plus the square and the square root cancel, x squared plus 9 over 2 minus 2 times 3 is 6 root x squared plus 9 over 2 cos theta. Okay, if I take, let's take this over to that side, because I want to get cos alone, and I see it's negative here. So I'm going to jump this to the other side. I have 6 root of x squared plus 9 over 2 cos theta. And then on this side I have 9 plus x squared plus 9 over 2. And then I bring this over here, so I have minus x squared minus 9 over 2 minus x squared minus 9 over 2. X squared minus x squared is nothing. 9 over 2 minus 9 over 2 is nothing. So now I just have this. Let's divide now with this 6 x squared plus 9 over 2 divide by 6 x squared plus 9 over 2 like that, and I have cos theta alone. cos theta is 9 over 6 is going to be 3 over 2. If I divide by 3, divide by 3 over x squared plus 9 over 2. And that is what I want to come to. Great. Right. 7.3. If the volume of the pyramid is 15, calculate the value of theta. Right. So the volume of a pyramid, 7.3, the volume of a pyramid, they give me here the formula, is a third times area of the base, times the perpendicular height. Okay, so the volume, if the volume is 15, okay, the volume is 15, is equal to a third. The area of the base is 3 times 3. The base is the square with side length 3. So the area of the base is going to be side times the perpendicular height of the pyramid. It's that length that comes up here, which is on the sketch x. So x. Okay. So this produces 15 is equal to a third times 3 is just 3x. So this produces that x is 5. Okay, and I want to calculate the value of theta now. Since I have that, cos theta is equal to 3 over 2 root x is 5 squared plus 9 over 2. I'm going to just plug this into my calculator. 3 over 2 root 25 plus 9 over 2 gives me 0.276. What? So theta is shift cos of my answer 73.97. Okay, there we go. And that is question 7. That is all for this video. I'll see you in the next one.